Drew Thompson is he's a resource recovery program manager with the Wastewater Treatment Division in King County. So Drew is going to talk about the work that they've done over the course of almost nearly half a decade, and their approach is a little different. And I'm going to turn it over to Drew to talk about what they're doing as far as solar energy transfer and heat recovery. Drew?
Perfect. Thank you so much for allowing me to speak here today. I hope everyone can hear me all right. And like others, I wish I could also be there as well. So without any further delay, let's get started here. So as Michael mentioned, I'm Drew Thompson. I am from King County Wastewater, located in Seattle, Washington, and the project manager and the current lead for the sewer heat recovery program, which I'm here to talk about today. So moving forward, today's agenda, we want to talk about why and how we launched a sewer heat recovery pilot program for our private users. I want to go over some key components of our user agreement as well as our application. And then last two things, how our utility reviews potential projects and how we work with these users to make this a reality. And then I want to celebrate our first successful pilot project as well. So back in 2019, spring of 2019, we first drafted a contract template with help from our lawyers. We then took this out to the developer community and we asked them what they liked, what would be problematic, and then also we asked them to identify some deal breakers for us as well. We got a lot of feedback. We brought this back to our lawyers to see what could be done, what changes could be made, and we were able to resolve most of the deal breakers with a revised contract, which we took to our King County Council. And again, this was a template contract, so it would relieve the political pressure from the council somewhat of approving a deal for a specific project. And it also allowed for a fuller policy discussion as well. Now, happy to report that the council approved our contract template unanimously, but instructed us to implement as a pilot program and limit us to 3 projects at this time. And then we put out a call for projects in December of 2020, and we required that all potential users be at least 30% design for the project in its entirety. And this has allowed us to make sure we weren't holding space for projects that might not actually materialize. So one of the first questions we had to ask ourselves was, how does sewer heat recovery help the environment? Well, we've learned that reclaiming wasted thermal energy is more efficient than any form of energy generation. Thermal energy contained in the world's sewers is an enormous untapped resource. There's been estimates that 90% of the energy used to heat water is flushed down the drain with that water. And sewers worldwide, as you've seen from other presentations today, have an average temperature of about 65 degrees. And then personally in our own system, I've seen temperatures as high as 75 degrees. Commercial and multi-family buildings account for about 22% of countrywide greenhouse gas emissions. And then the U.S. Department of Energy estimates that 350 billion kilowatts are discarded annually down drains in the form of heated water. And as a frame of reference of what this really means is annual U.S. commercial building energy consumption is approximately 1,200 billion kilowatts annually. So in theory, sewers contain enough energy to supply about a third of our commercial building heating needs. So moving on, why would developers be interested in sewer heat recovery? Well, there's a couple great possibilities or great options. It lowers a property's carbon emissions and water use. It helps meet more stringent energy codes. It helps leverage green building efforts to attract tenants, buyers, or investors. And then there's also financial incentives to help fund these type of projects as well. We have the C-PACER, the utility rebates, and then in some areas, there's also possible renewable energy credits available as well. In King County, we also had an independent consultant look at the conceptual applications and found that energy costs for building owners would go down anywhere between 29 and 45%. Carbon emission reduction was between 34 and 71%, depending on the building type. And then for cooling applications, the annual water consumption reduction was estimated at about 985,000 gallons a year, which is quite significant. So the other side of the coin is always, so that's why developers might be interested, or users. But then why would utilities like wastewater be interested in itself? Well, in King County, we are committed to helping our region reduce its carbon emissions and potable water use. So it also helps our community lower its carbon emissions and potable water use. There's a sharing of resources that can benefit the overall good. And then the user fees are a potential new revenue source for us as well. And then as well as the renewable energy credits I talked about on the previous slide, these also are a new revenue source, potential revenue source for us as well. So it's really a circular benefit to the community, whereas the community sees the reduction in carbon emissions and potable water use. We're able to generate some funds from sewer heat recovery, which they could go on to fund other efforts as well. And as Michael indicated, so in the past about half a decade, we've been formally launched, but honestly, over the last decade, we've been approached multiple times by private developers who are interested in sewer heat recovery. And for various reasons, it hadn't worked out yet. And one key barrier that had been that user agreements need to be ratified by our county council first. And our users' timelines move very quickly, and the legislative timeline tends to be on the slower end, which these really don't align very well. So when we approached this again in 2020, we got a pilot program approved, and then we had these following goals and commitments that we wanted to make sure we stuck to. So the first goal is help our community lower its carbon emissions, as mentioned previously. We have a template contract to provide users with transparency and speed. And then we also want to have reasonable compensation to our ratepayers, which is the primary reason we're in a pilot right now, is to assess what that energy transfer fee would look like. That's reasonable. Some commitments that we have is, first and foremost, we're a wastewater utility. We convey and treat white wastewater, and that is our primary mission. It is not to generate revenue, right? We want to have a positive impact on our community. We'll make sure we do it in a responsible way. Another commitment we have is that the user bears all costs and risks. That includes reimbursing us for our staff time that's committed to this effort. And then our last commitment, which I've mentioned already, is that we're limited to 3 pilot projects to assess that appropriate energy transfer fee. Now, when we're in an agreement with our users, and even before that, when they're coming to us with information requests, we always want to lead with customer satisfaction first. We aim to work with any interested users throughout the entire process and are committed to sharing our documents and knowledge with these potential users. We want to make this as easy as possible. Key factors that go into looking into this technology are the proximity to the conveyance pipe. It's a lot easier to tap a pipe that's a block away than a mile away. And then also the heat and flow that is in that desired location. And this equates to also making sure this meets the energy needs of that building or district who's interested. So on screen right now, hopefully everyone is seeing I just want to check the chat real quick. Okay. What you're seeing right now is an interactive map that's actually on our website right now. And what it allows you to do is type in an address. And the address that you see right now is actually the technical home office for King County Wastewater. And it allows you to see the conveyance pipes that are around that area that are available for sewer heat recovery. And so how this works is a potential user would look at this map and say, okay, great, there is a conveyance site in our area. Let me reach out to whoever the lead is, whoever the contact for the program is, and get some historical temperature and flow data. And then as well as any as-built drawings that can help confirm the depth of that pipe. It also has the pipe type on that, whether it be brick, concrete, whatever it might be. And then be able to assess, are there any other factors that need to be considered by looking at those as-built drawings as well as that historical data. And so next is an example of, is a screenshot of our user agreement. Once again, this is on our website. And so some key things that we had included in this that really sold it was we have term and milestone commitments. So this makes sure that both parties are moving forward in earnest, essentially. So there's some off-ramps in case some certain commitments aren't hit. There's a thermal use area description in our agreement, essentially it's on a first-come, first-served basis where the first user has the rights to that thermal area, and any subsequent user that might be upstream or downstream of that user has to prove that they're not going to detrimentally impact that first user and their ability to draw out that heat energy. Now, we don't guarantee the heat potential whatsoever. That is done by the potential user. Also, we have user responsibilities for design, construction, operations. So there's some data requests that we want from them as part of being a part of this agreement. We also, once again, stress that wastewater treatment is our priority. So if there's any installation that would negatively impact our ability to process and treat wastewater, that's something we have to go through and make sure that we come to a solution with that user, if possible. Once again, as I referenced before, the user reimburses our utility for all the staff costs that goes into reviewing that design, working them through the design process, and then also onto construction as well. And then the user shares half of any renewable energy credit revenue with us as well. And so one thing I want to highlight is that I talked about this energy transfer fee, but that is waived for the first pilot projects for the first 3 years, so that we can collect the necessary operations and maintenance data to really make that effort, see if to make sure that rate that we come up with is reasonable for our ratepayers. And so our application process is very robust. We want to make sure nothing gets doesn't looked at when we're going through this. So this is a graphic showing all the different groups in our utility that take a close look at these applications when we receive them on the onset, and also through the review process as we move from 30 to 60 to 90 onto 100% design, and then through construction as well. So we have everyone from engineers to construction management, operations and maintenance staff, reviewing these applications, looking through their lens for any potential impacts to our ability to convey and treat wastewater. And so finally, this is something we've been waiting to talk about for so long. It's our first successful pilot project. It's a partnership with Alexandria Real Estate, and it's still under construction. The overall campus is under construction. But however, our sewer pipe was successfully tapped just a few months ago, started in July and ended in early August, and we're awaiting completion of the above ground building before it is operation. And as you can see, it's located in our South Lake Union neighborhood in Seattle, and it's really in the shadow of that iconic Space Needle. So, what a great shot for our first successful pilot project. So I want to move on to some specifics of what this project is. What our sewer heat recovery is going to supply about 70% of that campus's heating from our sewer heat recovery. It's going to result in 99% lower carbon emissions anticipated compared to typical laboratory buildings of this same nature. It's a 4-building system that it equals about 1.3 million square feet. It's one of the 2 largest systems in the United States, and this is a closed loop system specifically for heating. And as I said, we were successfully tapped this back in July of 2023, and then the construction of their campus above ground is still ongoing, hoping to complete soon. So that's the end of my presentation, but in summary, this sewer heat recovery really does allow us to make beneficial use of a previously wasted resource. It's great for the community, developers, and the utilities, and our template user agreement allows us to move quickly to meet the timeline of these private developers and users. And so we currently have 2 open slots in our pilot program still, and this is on screen is our program website, where we have the user agreement, application process, and materials interactive map, as many other resources as well. So that's my presentation. Thank you so much.
Thank you, Drew. And congratulations on your first pilot. To see that actually go from concept, vision, and to actual reality is very rewarding. So congratulations to you and your team. We have one more
Thank you.
presentation. Thank you, Drew.